Student, I am SK sir. Today I am going to discuss on topic valence electron. First, we have to know that what is valence electron. It is the number of electrons that present in an outermost shell of an element are called as valence electron. It is denoted as VE. VE, that means valence electron. It is shortly described. Now, before deriving the valence electron from electronic configuration of element, first we have to learn how to write electronic configuration. If we know about electronic configuration, we can easily derive valence electron. Now, here examples are given in which element and its electronic configuration and beside it valence electron are also mentioned. Now look, first hydrogen. We know that Z of hydrogen is 1. Then we write it electronic configuration 1s1. Here 1 is denoted as shell, S is subshell, and 1 is number of electrons. So it is known as outermost and innermost shell. So here valence electron is 1s1. So valence electron that is present in this shell is 1. So valence electron is 1. In helium, we know that Z of helium is 2. So we write it electronic configuration 1s2. In this element, outermost shell is 1s2. So we have to derive the number of electron from its outermost shell. It is 2. So valence electron is 2. In this way, we derive very easily. Now, next element, lithium. We know that Z of lithium is 3. So we write it electronic configuration 1s2, 2s1. Now in this element, the outermost shell is 2s1 and number of electron present in it 1. So its valence electron is 1. We can easily derive it if we know about the valence electron. Now beryllium. Now we know that Z of beryllium is 4. So we write it electronic configuration 1s2, 2s2, and in this element electronic configuration outermost shell is 2s2 and number of electron that is present 2. So the valence electron is 2. Now we look the next element, boron. Here we know that Z of boron is 5. So we write it electronic configuration 1s2, 2s2, 2p1. Now its outermost shell is 2s2 and 2p1 and number of electron present in shell 2 and 1. So valence electron is 3. We write it. Now next carbon. We know that Z of carbon is 6, so we write it electronic configuration 1s2, 2s2, 2p2. So in this element, the last and outermost shell of the carbon is 2s2 and 2p2, and number of electrons that present in it 2 to 4. So valence electron is 4. Now next, nitrogen. Its Z of nitrogen is 7. So we write electronic configuration 1s2, 2s2, 2p3. We know that the outermost shell of nitrogen is 2s2 and 2p3. So we have to add 2 and 3 electron. That means valence electron is 5. In this way, we easily derive the valence electron from any electronic configuration of element. Now we see the next element, oxygen. Here we know that Z of oxygen is 8. So we write it electronic configuration 1s2, 2s2, 2p4. Now its outermost shell is 2s2 and 2p4, and number of electrons that present in it 2 and 4. That means valence electron is 6. Now next, fluorine. We know that Z of fluorine is 9. So we write 1s2, 2s2, 2p5. Now its outermost shell is 2s2 and 2p5, and number of electrons that present in it 2 and 5. So we join it. Now valence electron is 7. Now we know that next element, that is the neon. Here we know that the Z of neon is 10. So we write it electronic configuration 1s2, 2s2, 2p6. Now its outermost shell is 2s2 and 2p6. So here electron is 2 and 6. That means 8. Its valence electron is 8. Like this, sodium. We know that the Z of sodium is 11. So we write it electronic configuration 1s2, 2s2, 2p6 and 3s1. So its outermost shell is 3s1. Now number of electrons that present in this shell is 1. So its valence electron is 1. Now next element, magnesium. Z of magnesium is 12. So we write it electronic configuration 1s2, 2s2, 2p6 and 3s2. Now we know that its outermost shell is 3s2, and number of electrons that present in this shell is 2. So valence electron is also 2. Now we see the next element, like aluminium, in which we know that the Z of aluminium is 13. So we write it electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p1. Now we know that we have to derive the outermost shell. Now we derive, and number of electron 2 and 1. That means valence electron is 3. So we derive the next element, valence electron. Now silicon. We know that the Z of silicon is 14. So we write it electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p2. Now we know that its outermost shell is 3s2 and 3p2. So number of electrons that present in it 2 and 2. That means 4. Valence electron is 4. Now Next element, phosphorus. We know that Z of phosphorus is 15, so we write 1s2, 2s2, 2p6, 3s2 and 3p3, and its outermost shell is 3s2, 3p3. Number of electrons that present in this cell 2 and 3, that means 5. So valence electron is 5. In this way, we write electronic configuration of any element very easily. Now see the next element, sulfur. We know that Z of sulfur is 16, so we write it electronic configuration 1s2, 2s2, 2p6, 3s2, 3p4. We know its outermost shell of the sulfur is 3s2 and 3p4, and number of electrons that present in it 2 and 4. So we calculate it, valence electron is 6. Now we take next element, chlorine. We know that the Z of chlorine is 17, so we write it electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p5, and we know that its outermost shell is 3s2 and 3p5, and number of electrons that present in cell 2 and 5. So we calculate it, valence electron is 7. Now next element, argon. Its Z of argon is 18, so we write 1s2, 2s2, 2p6, 3s2, 3p6, and its outermost shell is 3s2 and 3p6, and number of electrons that present in it 2 and 6. So we calculate it, valence electron is 8. In this way, we write electronic configuration very easily. Now we see potassium. We know that the Z of potassium is 19, so we write it electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now we know that its outermost shell is 4s1. So number of electrons that present in this cell is 1, so valence electron is 1. Now next element, calcium. We know that the Z of calcium is 20, so we write it electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2, and now we derive its outermost shell 4s2, in which number of electron 2 is present, so valence electron is 2. Now in this way we easily derive electronic configurations and its valence electron from its outermost shells. Before deriving it, you have to go in comment section and get links to know the electronic configuration, how to write, and getting this video you can easily solve valence electron of electronic configuration of any element. If you like this video, give comments. Thanks for watching this video.